Okay, folks, we have been spending the last few days talking about how to graph trig functions, specifically sine and cosine, when you're given the equation. And today, we're going to be doing the exact reverse of that process. So instead of being given the equation, you're going to be given a section of a graph, and you're going to be asked to construct either a cosine equation or a sine equation that would create that graph that you're given. So one of the things that I put, that I drew right here at the top of the notes page, is I just put a reminder for how the parent function looks for sine and how the parent function looks for cosine. This is something that we've been studying the last several days. We know the parent function for sine, it touches the midline, beginning, middle, end. It goes up first and then it dips down second. The cosine wave actually only crosses the midline in two locations, 1/4, 3/4 mark. It begins high, in the middle is a deep valley, and then it ends high at the exact same level there. Okay, you can see that there are some steps that I have off to the side here, and I'm going to just kind of walk you through these steps for these problems. I think the one thing that I just want you to notice right off the bat is when you look at the graph that you're given, pictured in the graph is often more than one cycle through a wave. Okay, and I think it's important to note that there's lots of different correct answers to these problems. So one person might see a sine wave and another person might identify a cosine wave. So let's start with our steps here for how to write an equation when you're given the graph of a sinusoid. That's a generic word for either a sine wave or a cosine wave. So first it says you should choose a wave. Okay, so what you want to do is you want to look at the graph and you want to mark on the graph where you see the beginning of a sine wave or cosine wave happening and where you see the end of that particular wave happening. And again, please keep in mind that there are sometimes more than one choice. In fact, this particular problem, there are 3 different ways of doing it. The 2 examples that we're going to look at today, we're going to do both of them 2 different ways just to kind of show you how there's multiple ways to do this. So here's one thing that I noticed, and just to make sure that it's clear here, this dotted horizontal line that you guys are seeing here in the graph, this represents the midline right here. Okay, so again, we said the sine wave touches the midline, beginning, middle, and end. So if I can find a spot where this wave is touching the midline in 3 locations, and I see here there's technically 4, but I just need to pick 3. So I'm going to go ahead and choose, it's always kind of a good idea if you can get away with it, picking a wave that starts right on the y-axis. Okay. You can't always do that, but in this case, I see that right on the y-axis is a spot where this wave is hitting the midline. So that makes me feel like that's the beginning of a sine wave. And if I kind of follow through and say, well, it's hitting the beginning, it's hitting the middle, it's hitting the end, it feels like the end of this sine wave would land right there. So I'm just kind of marking off where sine is starting and where sine is stopping. Okay, so there I have identified my wave, and what you're really going to do, and we're going to do this problem 2 different ways, so I'm going to go back and erase what I'm crossing off right now, but you want to just kind of ignore any of the extra portion on the graph that's outside of where you have identified an individual single cycle through, in this case, a sine wave. So let's go ahead and jot down here. We're going to first identify what our wave is, so I'm just going to write sine on that line. Okay, and then the second step is we want to say yes or no. Does it look like that wave that we have picked out is flipped across the midline? And that's why I drew these parent graphs here. You can see the parent graph typically starts up, then dips down. That feels like that's exactly what's happening here. So I'm going to say no, this wave does not feel like it has been flipped over the midline. Okay, step 3 says now we're going to record the amplitude. We're going to call that the A. The amplitude is the distance from the midline to either the highest point in the wave or to the lowest point in the wave. So it's not where that wave hits the y-axis. You have to count from the midline up 1, 2, 3, 4 units we're stretching up. That's the same distance we would be stretching down. So we're going to write down 4 as the amplitude. D is the midline. On step 4, they want us to record where the midline is. It looks like that dotted midline is hitting right at -1. Okay, and then what we're going to do is we're going to go ahead and write part of the equation. Now, I just want to make sure it's clear here that when we write these equations, and typically you would have numbers where you're seeing me write the A, the B, the C, and the D. Of course, this could either be sine or cosine right here, but right now we have the A value is 4, and we have that the D value, the midline, that's -1. Okay, the piece that we're missing is we don't know the values for B and C, and of course we know X is also in there after sine, but I'm going to go ahead and write what we know. Okay, so I'm going to put 4 in for the A, sine. I'll leave a spot here for the BX plus C, and then at the end I'm going to put the -1, that's the midline there. Okay, now just by the way, had we said yes that this wave was flipped, then we should put a negative in front of our amplitude, making that -4. But the wave would have had to have gone down first and then up for it to have been flipped. Okay, and so now what we're going to do is we're going to do this 5th step here, and it says we're going to set up the following inequality. Okay, here's what you're going to set up. You're going to put an X in the middle of your inequality, and on the left side, you're going to put where your wave begins, and on the right side, you're going to put where your wave ends. Okay, so here's how this will look. We're going to do this right here where it says calculate Bx plus C. So I'm going to put X in the middle, and it looks like on my graph, right here where I chose my sine wave to start, it's starting at an X value. See how these are labeled in degrees? This problem is in degrees. This is starting at 0 degrees. So I'm going to put 0 degrees on the left, and then on the right I'm going to put where this cycle, this period ends. It looks like where I marked off it ending, looks like it's ending right here at 40 degrees. Okay, now here's what the goal is. The goal is, if we're in degrees, which is how this problem is, you want to make sure the left side of your inequality is a 0 and the right side is a 360. The significance in those numbers is if we think back to just the parent graphs, those graphs, their kind of cycle through the wave starts at 0 and it takes 360 degrees to make it through one full cycle. And so we want to restore the left side to a 0 and the right side to a 360. Now if you look at this, you'll notice the left side is already a 0. So that's good. That was kind of the advantage of picking a wave that started right on the y-axis. So I don't need to do anything to change that to a 0, but I need to turn this 40 degrees into a 360 degrees. Now let's think about a couple different ways we could do that. I suppose you could say that if we added 320 degrees to this, that would make it 360. The issue is whatever you're going to do to one section of this inequality, and there are 3 sections here, you have to do that same operation to the other 2 sections. Now, I don't want to do something to this far right section that if I did that to this far left section, it would change that 0 to a different number. I need to keep the left part a 0. So me adding 320 degrees wouldn't be a great idea because then I'd have to add 320 over here to the 0, and that would no longer be 0. So when you're changing the number on the right side to 360, you really want to do that by either multiplication or division. That way, if you multiply 0 by a number or divide 0 by a number, it'll stay 0. So I think the question we have to ask ourselves is, does 40 go into 360 evenly? And the answer is yes. It goes in there exactly 9 times, which means if I multiply 40 times 9, that'll get me 360. But I have to do that to the middle section where the x is, and I also have to do that to the 0. But that's still going to stay a 0 on the left. In the middle, I have 9x, and now on the right, I have 360 degrees. Okay, so whatever is in the very center after you have a 0 on the left and a 360 on the right, that represents what you're going to fill in as the bx plus c portion. Apparently the c in this problem is a 0. Okay, so this particular problem, if we were to graph this equation in degree mode, it would create this wave that you're seeing. Okay, now keep in mind, we know that these waves are cyclical, they're periodic, they repeat themselves over and over and over again. That's why in a lot of these graphs you see more than one cycle through a wave, but we just want to be focusing on one cycle at a time here. Okay, so let's go ahead and try this problem where we're picking a totally different wave. So I'm just going to erase all my markings that I put on the graph just so that we can try to pick a different wave. And this time I'm going to try to pick a cosine wave. Okay, remember how the cosine wave looks? I have the parent function graphed over here. Okay, it creates one big valley, or I suppose if it's flipped, it would start low and create one big hill and come back down, which is what I kind of feels like I'm seeing right here. Okay, right here feels like this is the very, very bottom part of maybe a cosine wave. And if I were to kind of just follow this wave, here it creates the top of a hill, and then we come all the way back down. Over here feels like maybe this is the end of a cosine wave. And so again, I just want to kind of block out these other sections here. This feels like a cosine wave that actually has been flipped because I've got a hill there. So I'm going to go ahead and fill in the wave I would be choosing if I were going to do the problem this way is a cosine wave. I'm going to say yes to the flip. The amplitude and the midline doesn't change. That is always going to be a 4 for the amplitude and a -1 for the midline on this particular problem. I'm going to go ahead and fill in what I know so far. Notice that as I'm writing this, I put a negative sign in front of the 4 because we said, yes, this cosine wave is flipped. Okay, and so now that brings us to finding the bx plus c portion of this problem. Now remember, we're supposed to mark where this cosine wave begins, that goes on the left, and then where the wave ends, that goes on the right. Well, now the cosine wave that we chose here, it looks like it's starting at -10. So I'm going to put -10 degrees over there. And then it looks like it is ending, let's see, there's not a number on this dot, but it feels like each dot is counting by 10 degrees. So if I'm at 1, 2, 3 dots over, this would be 30 degrees there. So I'm going to put 30 degrees here. Okay, now remember what the goal is. The goal is I need the left side to be a 0. We want to do that first. And then we want the right side to be a 360. Now, if the left side is not initially a 0, like it was when we chose this other wave up here, then you should make that a 0 by addition or subtraction. So I'm going to add 10 degrees. That's going to turn that to a 0, but whatever we do to the left side, we have to perform that same thing to all 3 sections here. So now I have 0 on the left, x plus 10 degrees in the middle, 40 degrees on the right. Okay, so I've got my 0 on the left. I need to turn 40 into 360, which is the exact same thing we did up here with this problem. So I'm going to multiply 40 by 9. I need to make sure I'm careful and multiply the middle, x plus 10 by 9. And when I say careful, that 9 needs to be distributed to both the x and the 10. And then you're going to multiply the 0 by 9, which keeps that side a 0. Okay, when we simplify all this out, you can see what's in the middle here is 9x plus 90. That's what we're going to squeeze in here as the bx plus c portion of the equation. Here is also another equation that if you were to graph this graph and this graph up here both create this exact same graph. Okay, and so this is what I'm saying about how there can be multiple correct answers to the same graph. Now, we're not going to do this problem a third way, but I just want to show you how you could have chosen this wave right here as another sine wave. Had you chosen that, it looks like that one, that sine wave, would start at -20 degrees. It looks like the sine wave would end at +20 degrees. Okay, now let's look at just one more problem here. We'll look at this one, but I want to look at one in radians. And we know that this is in radians because as you look at the x-axis, you can see that it's labeled with pi symbols here. Okay, now there are several different waves that you could select on this graph. I see 2 cosine waves and I see 3 sine waves. That means there's 5 different ways of doing this problem. Okay, I'm going to show you what all of them are here real quick. Here is a sine wave. Here's another sine wave. Okay, notice when I'm doing the sine waves, see how they're hitting the midline, beginning, middle, end? Okay, and here is one more sine wave. Those are the 3 sine waves that you could choose. Here is a cosine wave. There's one. And then here is another cosine wave. Okay. Now, of all of those options, the one that I would be drawn to is I would be drawn to this sine wave simply because it is starting on the y-axis, which means I can say that it's starting at 0 radians instead of 0 degrees. So that's going to be the one that I'm going to go ahead and choose, but you could choose any of the 5 that I just highlighted. I'm going to go ahead and write down sine here. Now, this particular wave, if you compare it to the parent wave that I have sketched up above, see how this starts down and then goes up? Well, the parent wave goes up and then dips down. So because this goes in the reverse direction, I'm going to say yes, that this is flipped. If you count the amplitude from the midline, how far are we stretching down or up? Just so happens this is the same amplitude as the previous problem. And then where that dotted midline is located looks like it's at 3. Okay, I'm going to go ahead and build my equation. Notice this time I am going to put a negative in front of the 4, my amplitude, because we said yes, that we were flipping this. Okay, now we're going to calculate the bx plus c portion. So you're going to put x in the middle, and then you're going to mark where does this wave start. Well, it starts at 0 radians. The wave we chose here, it looks like it's ending at 8 pi radians. Okay, now I want to draw your attention here to the notes. On the notes, it says if you're in radians, you want the left side to be 0. Well, that's good. We've got the left side already 0. You want the right side, instead of being 360, we need this right side to be a 2 pi. Okay, we want to do this, changing it into 2 pi by either multiplication or division. So I'm going to divide, I'm going to divide 8 pi by 4. That'll turn that into a 2 pi. And I'm going to do that to the same thing on each of these sections here. That way, 0 divided by 4 on the left side, that's going to keep that as 0. Okay, and whatever you have in the middle, once this is, oh, I shouldn't have put degrees there. Sorry. This is 0 radians. Okay, whatever you have in the middle, that x divided by 4, that's what goes in here for the bx plus c. Again, on this problem, the c value would have been a 0. Okay. Now I want to do this problem one other way. We'll just cross this part off here, just so that we can look at what if we hadn't picked that particular sine wave. Okay, I'm going to pick a cosine wave here. Okay, and I think we said that there were really 2 cosine waves that we could have selected. I want to pick one where it feels like it's not as obvious where it's starting and stopping on the x-axis, just to kind of talk through that little piece of this here. So the wave that I have chosen is this cosine wave. So I'm going to fill in cosine here. It does feel like that wave, yes, is flipped because the cosine wave is typically a valley, and here we can see it's a hill. Okay, the a value is still 4. The d value is 3. I'm going to go ahead and fill in negative in front of the 4 because we said it was flipped. I'm using cosine now, and to get this part right here, this is where we're going to calculate the bx plus c portion by, on each side of the x, we got to fill in where this cosine wave starts and stops. Now, it feels like each dot is counting by 4 pi, okay, by 4 pi here. So if this is by 4 pi, in the middle would be the halfway point from 0 to 4 pi. So we want to say that this would be, looks like that would be 2 pi, where that's starting. And where it's ending, see how there's a little dot right here? I think that would be 12 pi. So technically this wave ends halfway between 8 pi and 12 pi. I want to fill in 10 pi there. Okay, now remember the goal. The goal is I need the left side to be a 0. The right side, I want to restore that to a 2 pi. Okay, if the left side is not a 0, make it a 0 first by addition or subtraction. So I'm going to subtract 2 pi. That'll make the left side a 0. I have to subtract 2 pi from all 3 sections. So now in the middle, we have x minus 2 pi. And on the end, subtracting 2 pi from 10 pi, we have 8 pi. And then we're in the same situation we were here, how to turn 8 pi into a 2 pi. We can see that we divided by 4. So I'm going to divide everything in the middle by 4 and the 0 by 4. That gives me in the middle x over 4 minus 2/4 reduces to 1/2. Okay, so now what I have in the center here, that's what I'm filling in my equation as the bx plus c portion. Here is yet another equation. There are 5 technically that you could create that would kind of construct this graph that you see here. Okay, so I just want to mention something about the homework. On this worksheet, 12.7, 12.8D, you'll notice the answers are typed on the back, but that's not really a full comprehensive list of all the possible answers. A few of them might say, here's one answer or here's another, but there are some examples where there's, 4 or 5 possible answers. So I want to go ahead and show you. Now, these are just in addition to what I already have typed on the answer sheet. You only would need to have one answer. So I didn't include on this screen here the things I already have typed as possible answers on the worksheet, but I wanted to show you that these are other possible options. So if you're getting an answer and you're thinking, okay, that's not an answer that I see on the answer sheet, here are other possible answers. So if you want to pause the video and take a picture of this screen so that you have other possibilities to check as you're going through this, these are other options. Okay, you can go ahead and try that D worksheet. Sounds good.